love the chase and the hunt, and I set the pace when I'm running. I always
Namaste friends. Today in the entire chapter of Python, this chapter 90. So we are 10 short of 100. And the SciPy, this is chapter 4. So the previous chapter was Optimizer, lesson 3, where we saw two parts. In lesson 4, also it will be a two-part lecture because I don't want to go anything more than 5 minutes so that you would actually lose the track. So that is where I'm actually trying to keep. All right. So this chapter is called sparse data. So we are going to be seeing what a sparse data is, and like always, we are going to be practicing the same. All right. So this will be a two-part lecture. So a sparse data. I'm sorry, my apologies here. It is sparse data. I've kept the previous slide. Apologies for the same. So the sparse data, if we see is a data that has mostly unused elements. So elements that don't carry any information. So if we have a big data, there are a lot of meaningful data. Okay. Now say suppose traffic in a road. So the traffic also contributes to the weather condition. So you're actually making note of how many cars, how many bikes now actually traveled. The sparse data might be the amount of dogs which actually went through, which is a data which is mostly unused element, that it does not carry any information or relevant information. And it can be an array like 1 0 2 0 0 3 0 0 0. I mean, what would you interpret here? What would you say, what does it mean? You will not interpret anything here. Okay, so this is like a sparse data. So the sparse data is a data set where most of the item values are 0. Okay, so in this case where most of the item values are 0. The dense array is the opposite of sparse array. Most of the values are not 0. So sparse is most of the values are 0. The dense is most of the value is not a 0. In scientific computing, when we're defining with the partial derivatives in linear algebra, we will come across sparse data. So once again, it actually comes to the linear algebra, the derivatives, and we will deal with sparse data. So how to work with sparse data? The SciPython has a module called SciPython.sparse, okay, which is for the sparse data that provides function to deal with sparse data. There are primarily two types of sparse matrices that we use. Okay, SciPy.sparse only. So CSC is a compressed sparse column for efficient arithmetic fast column slicing. Compressed sparse column. CSR, compressed sparse row for fast row slicing, faster matrix vector products. Okay, for fast row slicing, faster matrix vector products. So CSC and CSR. We will use CSR matrix in this tutorial. Right? All right. So the CSR matrix is, we can create a CSR matrix by passing an array into the function SciPy.sparse.csr underscore matrix. So if you want to create this thing, a CSR matrix from an array, we actually take it like this. And we will actually paste it here. So basically import numpy as np, that is the same. From SciPy.sparse import CSR matrix. And then we say the numpy.array, which has got the sparse and this CSR matrix. Okay. So this gives 0, 5, 0, 6, 0, 8, 1, 1, 2. Well, what does it mean? The item 1 is in row 0, position 5 and has value 1. Row 0, position 5, value 1. Row 0, position 6, value 1. Row 0, position 8, value 2. So this is here 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 8, 2. So 0, 6. So this is the way it is actually going. See here, that is what it is. I trust this is a good start. And tomorrow we'll be continuing about the matrix. So let's actually stop here. I trust you have actually seen my lecture, enjoyed it, and probably understood it. If you have any questions, kindly contact me. I'll actually try to help you to the best of my abilities. Like always, I'd like to thank two persons. One is you for giving me a golden tie, and the other is my wife Jayashri, following me to follow my passion. Till we see next time, thank you, take care, and cheers.